3, 2, 1. Hello there, my name is Chian, this is Jiao, and together as Group 4 we'll be presenting on our Database Fundamentals final assignment. So for our final assignment, we chose to work on the second scenario, which is sunny housekeeping. So firstly, I'll talk about our expanded scenario and the few details that we've added into it. So sunny housekeeping is having a promotion where they are handing out free gifts to customers who have paid for at least one house service. Additionally, Sunny Housekeeping has also hired several new supervisors to manage its group of employees within its organization. So with a new expanded scenario, we would certainly have to add new business rules as well. To quickly go through them, an employee must have at least one and only one supervisor. Now every supervisor must manage at least one employee as well. A supervisor can take up more than one service, but not necessarily any. Each customer must be prepared a gift and only one gift. Similarly, every gift must be allocated to a customer and only one customer. So let's move on to the ERD. And as you can see here, the ERD that we've drawn up conforms to the business rules that we've mentioned earlier ago. So the service acts as the main event table, and its relationship with the house table is that the service references the house, where the house table references the customer table, which then references the gift table. Now on the other hand, the service table references supervisor table as well, which itself is referenced by the employee table. Onto the RDM. As you can see here, not much difference between the RDM and the ERD that we've displayed earlier ago, except for the fact that each attributes of every entity table is listed, as well as its primary key and foreign keys. It should be noted that each entity table uses its own unique ID number as its sole primary key component. We have the written RDM as well, and this would form the basis of our SQL script that we will use to create the tables in our database. So as you can see here, this is our script for creating the tables in the database. So firstly, let's talk about the constraints that we've added to our tables when designing our database. So first up, we have a check constraint that makes sure that only two gender values are accepted in the tables, namely male and female. As you can see, we have a check constraint for gender in supervisor, as well as an employee. We also have a unique constraint for every phone number column in every table to ensure that no two phone numbers are ever the same, as visible here in supervisor, employee, as well as customer. Now we also have another check constraint for salary column under the employee table to make sure that all base salaries of every employee is above a given minimum, that is 1,500. We also have another check constraint for the house type column under the house table to ensure that only 4 given house type values are accepted, namely CD, AP, SD, and BG. Lastly, we have several not null constraints throughout all tables in the database to ensure that important columns are not left out. For example, in the house table, we can see that all columns relating to the address of the house itself are given a not null constraint because it is vital that the company has data on the location of each house that it provides services to. So very quickly, I'll scroll through all these. Now as you can see here, these lines will insert values into the table that we'll create, and I'll run the script just to show you that it works. Okay, very quickly. scroll through everything just to show you that no errors are present. Right. And to show you that we've created the tables, we have the customer table here, the employee table, gift table, the house table, service table, as well as the supervisor table. Now all these tables are designed to conform to the third normal form in normalization, where there are no repeated groups, no partial and no transitive dependencies, as you have just seen. However, a delayed anomaly remains in our database. So as an example, if we go to the employee table, we can see that each row has a unique data on each unique employee. But let's say that employee with an ID of 2013 resigns from the company. So if said employee resigns from a company, we would have to delete its data from the employee table, and any information on that employee would be lost forever. And that marks the end of my presentation. Moving on, I'll be passing it to my partner Jiao to continue.
Alright, I'll be showing 4 user queries for the part 4. So for the first user query, following part 4a requirement, that is user query with subquery and 2 new date functions. And we have the scenario such as the management of Sunny Housekeeping wants to gather all supervisors who work on services in the first quarter of the year to reward them for their outstanding performance with their service dates rounded off to the nearest month. So first we will select the supervisor table and get the supervisors that work in the first quarter of the year, and we will round their service dates to the nearest month using the 2date function, round, and 2char function, and the 2 new date function that we use is 2char and round. And if we run this, we will get the output of supervisors who work in the first quarter of the year after their service dates rounded off to the nearest month. It is 4 distinct supervisors, as you can see here, that fulfill the condition. And for the next user query following part 4b requirement, that is 4 join table and 2 user condition with group by and having clauses. We have a scenario where a survey company wishes to gather groups of male customers from Sunny Housekeeping with more than one service provider, in which these services are carried out by male supervisors for statistical purposes. So first, the 4 tables joined are customer, house, service, and supervisor. And then we will have our 2 user condition, that is that customer gender must be a male, the supervisor gender must also be male, and we will use the group by clause to group the customers by their first name, last name, phone number, and then where they must also have more than one services from Sunny Housekeeping with the having clause. And if you run this, we will get that data. From our data, we will only have this guy, Daniel Hill, with more than one service, and is a male, and its service is also only supervised by a male supervisor. And for the next query, following the part 4c requirement, that is a right outer join table and 3 user condition. We will have our scenario where Sunny Housekeeping wants to keep track of all male supervisors with names that begin with J or L, whose employees reside in the town Petaling Jaya or Putrajaya, including those supervisors that are not assigned to any services. So we will first have the service table right after join with the supervisor table to show supervisors that are not assigned to any services but fulfill the 3 conditions. So for the first condition, it will be that the supervisor's gender must be a male. The second would be we will look for the entry from our data that the employee's town value must consist of the word Jaya. And the last condition would be that the supervisor's name starts with either J or L. And if we run this, we will get the name of the supervisors who fulfilled the requirements, including those that are not assigned to a service. You can see from the data that one of the supervisor has not assigned to a service ID, but if it has 3 of those user conditions fulfilled, it will still be shown. And for the last user query, following part 4D requirement, that is a unary join, we have our scenario where Sunny Housekeeping is forming a tally of amount of houses for all house types. So we will first have output a data table of 2 columns with the name house type and amount of house types, with our first row value example as BG. And we will then choose 2 tables with the alias main and BG to count the number of houses of house type BG. And we will also repeat this process for the other 3 house types, that is AP, SD, and CD. And if you run this, you will see the table that shows the amount of houses for each house types. For AP there is 5, at BG there's 4, for CD there's 4, and for SD there's 7. And that marks the end of our presentation. Thank you.